Hi, this is Thomas. Welcome back. This is part 3 of binomial expansion. We're now going to look at a more advanced example of applying the binomial theorem. We learned the binomial theorem in the previous part of this lesson. We'll now see the binomial theorem in sigma notation, which is x plus y to the power of n. The sum for r equals 0 to n of the binomial coefficient n over r times x to the power of n minus r times y to the power of r. Now let's apply the binomial theorem to the binomial 2x squared minus 3 over x to the power of 4. The values that we can identify in the binomial theorem are x, which in this case is 2x squared, and y, which in this case is negative 3 over x, and n, which in this case is 4. Now the value r is simply a development from, as the summation notes, from 0 up to n. So in this case the r range will be from 0 to 4. So let's work through our terms individually. For 2x squared minus 3 over x to the power of 4. Our first term, the coefficient is going to be n over r. N is 4, and we're starting with an r of 0, times x, which is 2x squared. It's very important to put this entire term in parentheses, to the power of n minus r. N is 4. R beginning is 0. Times y, let's also put y in parentheses, minus 3 over x, all to the power of r, and in our beginning term, r is 0. And we're summing. Summation notation means we're going to add and continue with this process of creating the term, adding the next term which we create, etc., until we get all the way through to r equaling our n, until r equals 4. So next is n over r will be 4 now over 1. This is the next r in the series. And the x term, 2x squared, is going to be to the power of 4 minus 1, because again r is 1 for this term, times negative 3 over x to the power of r, which is 1, plus, and we continue, 4 over 2 times 2x squared to the power of 4 minus 2 times negative 3 over x to the power of 2 plus 4 over 3 times 2x squared to the power of 4 minus 3 times negative 3 over x to the power of 3, and one final term, plus 4 over 4 times 2x squared to the power of 4 minus 4 times negative 3 over x to the power of 4. Now that's a long expression with a lot of opportunity for simplification, which is our next step. For our simplification, we need to understand the binomial coefficient. So as a reminder, up at the top of the whiteboard, I'll show the binomial coefficient procedure. N over r equals n factorial over r factorial times n minus r factorial. And we're going to begin with the binomial coefficients. I won't work through the calculation using this expansion. I'm simply going to recall that the numbers that we calculate in the binomial coefficient, those match to or derive a particular row of Pascal's triangle. Now, since our binomial is to the fourth power, we're working with the fourth row of Pascal's triangle. So I'll start by simplifying the coefficients from the binomial coefficient, and those values are going to be 1, 4, 6, 4, 1. That is the fourth row of Pascal's triangle. You can confirm those values using the formula for the binomial coefficient. Those are the initial pieces of each of these 5 terms. Now to continue, 2x squared to the power of 4 minus 0, in other words, to the power of 4. This is not 2x to the power of 8. This is, we'll expand step by step. This is 2 to the power of 4 times x to the power of 2 to the power of 4, which is x to the power of 8, times negative 3 over x to the power of 0, which is simply 1, times 1. Now continuing on, plus 4 times 2x squared, all to the power of 4 minus 1, which is 3, will be 2 to the power of 3, times x squared to the power of 3, which is x to the power of 6, times negative 3 over x to the power of 1. Now I want to separate the negative 3 from the x, so I'm going to multiply by negative 3 over 1 times 1 over x. And of course negative 3 over 1 can simplify to negative 3. But in some binomials, the term might be, for example, negative 3 over 5x. And so if we have a value other than 1 as the coefficient of x, it's important to understand how we handle the full fraction mathematically. So here I'm going to stick with negative 3 over 1. Going on to the next term, we have our initial coefficient of 6, 2x squared to the power of 4 minus 2, or to the power of 2, which will give us 2 to the power of 2, and x squared to the power of 2, which is x to the power of 4. Then times negative 3 over x squared. This is times negative 3 over 1 squared times 1 over x squared. I didn't include the addition. I'm going to go back and put the addition sign in front of that 6. That completes the third term. Now moving on to the fourth term, plus 4, which is the result of the binomial coefficient, times 2x squared to the power of 4 minus 3 is 1. So that's simply 2 to the power of 1 times x squared to the power of 1, which is x squared. And again, I don't need to show that expansion, but to emphasize that we're really dealing with two parts that we're applying the exponent to. Even here with a very simple exponent of 1, I'm going to expand to emphasize that that is an important consideration in your calculations. Continuing to negative 3 over x to the power of 3 will be times negative 3 over 1 to the power of 3 times 1 over x to the power of 3, plus our final term, the initial coefficient is 1, times 2x squared to the power of 4 minus 4 is 0, so that entire expression is simply 1, times negative 3 over x to the power of 4, which is times negative 3 over 1 to the power of 4, times 1 over x to the power of 4. Now my objective in this step was to clearly separate the constants from the variables. So I'm going to go through and mark and underline all of my variable components. X to the power of 8 in the first term, x to the power of 6, and 1 over x in the second term. x to the power of 4, and 1 over x to the power of 2 in the third term, x to the power of 2, and 1 over x to the power of 3 in the fourth term, and 1 over x to the power of 4 in the fifth term. And all other values are constants. And now I can complete my simplification. I'll calculate the constant value. That will be multiplied by a variable, and we'll do that for all 5 of our terms to arrive at our fully expanded binomial expression. So starting with our first term, 1 times 2 to the power of 4 times 1. Those simplify to 16. And we only have one variable term, x to the power of 8. Now going on to the second term, we have 4 times 2 cubed times negative 3 over 1. So this will be a minus. Let's expand or multiply out 2 to the power of 3. That's 8. 8 times 4 is 32. 32 times 3 is 96. And because the 3 is negative, we have minus 96. And we have two x terms, x to the power of 6 times 1 over x, which is x to the power of 5. Going on to our third term, our constants are 6, 2 to the power of 2, and negative 3 over 1 to the power of 2. This will be a positive term. 6 times 4 times 9. 6 times 4 is 24, and 24 times 9 is 216. And our x terms are x to the power of 4 and 1 over x to the power of 2, which leaves us with x to the power of 2. In the fourth term, our constants are 4, 2 to the power of 1, negative 3 over 1 to the power of 3. The result will be a negative term, 4 times 2 times negative 27, minus 216. And our x terms are x squared and 1 over x to the power of 3. Now here what we have is x to the power of negative 1, or 216 over x. And our fifth and final term, the coefficients are 1, 1, and negative 3 to the power of 4. So we'll have a positive term, 1 times 1 times 81. And we only have one variable term, 1 over x to the power of 4, which is x to the power of negative 4, or, as it's given, 1 over x to the power of 4, we can show as 81 over x to the power of 4. And that completes our binomial expansion. 16x to the power of 8 minus 96x to the power of 5 plus 216x to the power of 2 minus 216 over x plus 81 over x to the power of 4. So as we see here, a full binomial expansion takes some time. In some binomial expansion problems, the requirement is simply to calculate one term within the full expansion, and we can do that by applying the formula for the general term, which is what we'll learn how to do in the next video.